Alright guys, hello and welcome to today's lesson. This is Mr. Ludden and today we're going to have a look at inequalities and how to represent those on the number line. This is a follow-on lesson from the video I did on different types of numbers that come up in your Junior Cert and your Leaving Cert, and I'll put a link to that in the description below. If you haven't had a look at that yet, I would advise you to go back and have a quick look before you start this video. As well as that, any of the key notes that I go through in this video will be in the description as well. And if you keep an eye on the comments below, I'll have a comment with the timestamp of the different parts of this video. So what we're going to do is start off with a quick recap on our different types of numbers. We'll have a look at where you can find this information in your log tables. Then we'll have a look at some exam paper questions, how the questions are asked and how we're going to tackle them, and then I'll have my key points at the end. So very quickly, the three main types of numbers we're going to be looking at today are real numbers, natural numbers and integers. So the first three on your screen there. And just to remind you, your real numbers are your positive, negative, your decimals, your fractions, zero. Basically any number that you can find on the number line that you would have used in primary school and first year, second year, all the way up. Your natural numbers are your positive whole numbers, so your counting numbers. So it starts at 1 and then goes 2, 3, 4, 5, 6, all the way up to infinity. It does not include 0, so just be careful there. And your integers, which have z as their symbol, are like your natural numbers, except they go back to the left of the number line as well, so into your negative numbers. So as well as 1, 2, 3, 4, 5, they also include 0 and -1, -2, -3, all the way back to minus infinity. These are handy to know off the top of your head, but if you do get stuck and if you are unsure or if you forget the meaning of those in your exam, on page 23 of your log tables, they tell you what the natural numbers are. So if you look down at the second half of your page here, there we go. Your natural numbers are 1, 2, 3, 4, 5, 6, all the way up. Your integers are -3, -2, -1, 0, 1, 2, 3, and the dots either side here indicate that it goes on each way. And just down below that, your rational numbers is anything that can be written as a fraction, but your numerator here, your p, has to be an integer, so it has to be a whole number, and q has to be a whole number as well. They can be negative numbers, absolutely. And one more little term and condition, your q, so your denominator down here, the number at the bottom of your fraction cannot be 0, because if you think about it, if you have a fraction, let's say 2 all over 0, if you put that into your calculator will not be able to do it, because what you're asking your calculator to do here is divide 2 by 0. And if you think about that, it's impossible to come up with a real life situation where that might make sense. It's like, how many zeros are in 2? And if you think about that, adding up the amount of zeros, like 0 plus 0 plus 0, is still going to give you 0. So that's a sort of brief explanation about why they put this little bit here. Your denominator cannot be 0. So that's your log table. And that's going to bring us on to our exam questions. So this question came up in 2019, this is your question 7, and we're going to have a look through this now. So the A part of our question, I'll just make that a bit bigger, basically it's just asking you to define what are your natural numbers and what are your integers, and you have to be as specific as possible. So we can do that straight away. The set of natural numbers, as we know, are our counting numbers. So it starts at 1 and goes all the way up. So 1, 2, 3, 4, 5, all the way up to infinity. But we need to get that down on paper now, so we need to make sure that we get our marks. So I'm going to take the exact words that they've used in the question here, and I'm going to start my sentence with those words. So the thing that I've underlined here, the set of natural numbers n, I'm going to literally start my answer with that. So the set of natural numbers, and I'll put in brackets n, are the set of, first of all, they're positive numbers, and there are our whole numbers. And at this point here, I ask myself, well, have I been as specific as possible? Is there any way that someone might misinterpret any part of that? And just on that same train of thought, I'm going to add in just 2 words at the end, just to be as specific as possible. I'm going to refer to the number 0. As we know, the number 0 is not a natural number, so I'm going to put not including 0. Just so the examiner knows that I know what I'm talking about. So that right there will get us our full marks. When we have a look at the marking scheme in a minute or two, we'll just make sure of that, but spoiler alert, we're good for our marks here. I'm going to come at the second question here, A part II, in the exact same way. And I'm going to say this is the set of integers Z are set of positive and negative whole numbers and including 0. And again, that's going to get us our full marks when we have a look at the marking scheme. Just taking question 7a, part I and II, even if you knew nothing about maths, but if you knew how to use your log tables, page 23 basically tells you all that stuff that I've written down just before. So there and there would have gotten you your full marks if you could sort of translate that to English. So key point, be familiar with your log tables. They might get you out of trouble for a couple of your questions. Okay, 7 part A was just definitions. 7 part B is the main content that I wanted to have a look at in this video. Just before we try that question, and let me just make that a bit bigger. Before we try this question, just a brief recap on what the symbols actually mean there. So you've got your greater than symbol, which is this one. You've got your less than symbol, which is that one. You've got greater than or equal to, which is the greater than symbol, and also it's like they've sort of combined that with the equals sign. So this part here, if you can imagine like the bottom part of an equal sign, but also the greater than sign with it. And the same idea goes for the less than or equal to sign. Also, sometimes you might come across an equal sign with a line through the middle. That means something is not equal to something. So I'll just give you an example or two of how these are asked. So you might have that x is greater than 3. And what that means is that this number here is any number that you can think of that is bigger than the number 3. However, you'll be given a small bit more information. you'd be given like that x is an element of, let's say, your integers, just for example. So now you can't just pick any number you want for x. It has to be an integer, so it has to be a positive or negative whole number that is greater than 3. So for that, if you think about like numbers that are way bigger than 3, like 10 is going to be part of that, 100 is going to be part of that set, 5 is going to be part of that set, 4 is going to be part of that set, and you might ask, will 3 itself be part of that set? And in order to answer that yourself, you need to ask yourself, well, is 3 bigger than 3? And the answer to that is no. 3 is equal to 3, but it's not bigger than it. So in this case here, if we were to line up all of these numbers here in order, the smallest number that will be in that set is 4, then 5, then 6, then 7, then 8, and all the way up. 3 will not be a part of this set here, and let me just get rid of that. 3 will not be a part of this set here because 3 is not greater than 3. So again, this was just my sort of rough work, and this is the set that I'm talking about that matches up with this criteria up here. Just to use this same example and just to change it up slightly, instead of x is greater than 3 up here, I'm going to slightly change the sign in the middle, and I'm going to say x is greater than or equal to 3. And we'll keep this part here the same. X is still an element of z, so that means x is an integer. So I'll just get this part here away. That was just my rough work from the last question. The only difference between this new question here and my last one is the fact that my x can now be equal to 3 as well. So I'm going to take my first curly bracket away at the bottom. I'm just going to move it to the side here, because in this set 3 is allowed in this set here because of this part of your inequality sign. Okay, there's a small bit to get through there, or a small bit that you've done even, and it's important that you're able to wrap your head around that. So what we're going to do is get a small bit more practice on these equations, except this time I'm going to introduce a number line to represent the set that the inequality shows. So instead of like writing this part here, the set, to describe what this is talking about, we're going to use the number line because that's the way it comes up in exam questions. So I'm going to split this page here into two, and at the top here we're going to try and represent all of the numbers x that are greater than 3, and this time we're dealing with all the real numbers, so x is an element of R. So on the number line here, if we were to just start that out and try and just pinpoint a couple of numbers that are bigger than 3, well, we could say that 7 is bigger than 3, 8 is bigger than 3, 5 is bigger than 3, 4 is bigger than 3, 6 is, 9 is, 9.5 is, 7.5 is, and so on. Now remember, we're dealing with our real numbers, so we can have decimals there as well. So just watch, just between 8 and 9 here, 8.5 is going to be bigger than 3, 8.6, 8.7, and if I was to fill in all the numbers that are bigger than 3, what would happen is I'd end up with a line. This line here represents all the numbers on that part of the number line. And if I just put an arrow here, that indicates that this line is going to continue on forever, all the way up to infinity. However, if we look back to the left of this line, we need to know where it actually stops. So I'll just take this part here away. If we think of like 3.5, which will be there, that's going to be bigger than 3. 3.2 is going to be bigger than 3. 3.1. And we're getting closer and closer to 3 itself. But we need to know when to stop. So we need to get really, really close, but not actually hit 3, which is very, very hard to do. So to save you that hassle, the way we symbolize that is by drawing a circle around 3. Now, seeing as x is greater than 3, it's all the numbers that are bigger than 3, but it's not actually 3 itself. We are going to leave that circle here as an empty circle. So we're not going to color it in the middle. And that represents that this line here is all the numbers, all the real numbers that are greater than 3, but we're not including 3 itself. If you look down to the second part of the page here, it's literally the exact same question, except this time my inequality in the middle here is the greater than or equal to sign. So we're going to end up with the exact same numbers if you think about it. All the real numbers that are bigger than 3. But this time when I get down to 3 here, I'm going to draw a circle, but I'm going to fill it in. So it's a filled in circle. And what this tells me is that I'm representing all the numbers that start at 3 and go all the way up to infinity. So all the way up this way to infinity. But I am including the number 3 as my starting point. So just something to be aware of, and this will be in my notes in the description as well. If you are dealing with strictly greater than, you're going to do an empty circle. If you are dealing with greater than or equal to, you are dealing with a closed circle. And the same goes for your less than and less than or equal to signs. Okay, one more set of examples because I want to talk about when you're not dealing with real numbers, when, for example, you're dealing with natural numbers. So I have 2 examples here. We're going to try and represent this scenario here on a number line. And this tells us that x is greater than 2. So you have to think of all the numbers that are greater than 2 when x is a natural number. So all the natural numbers that are greater than 2. So if you think about your natural numbers, they are your counting numbers. So your natural numbers are 1, 2, 3, 4, 5, all the way up to infinity. On this number line here, remember our natural numbers now, we can't have 9.5. We can't have that there because 9.5 is not a natural number. So basically all you're going to be drawing are dots on the whole numbers. And they have to be bigger than 2, so strictly bigger than 2. So right now I've done 10, 9, 8, 7, 6, 5, 4, 3, and I get to 2, and I ask myself, is 2 going to be labelled with a dot? And the answer there is no, because my numbers here have to be strictly greater than 2. They cannot be equal to 2 because that inequality sign does not have the little line underneath it to indicate that you can include 2 in that set. Now on this number line here, you might say, well, 11, 12, 13, 14, all the way up to infinity will work as well. How am I going to represent that? And to answer that, I suppose, like we've answered this question as far as the number line that we're given is concerned, but in order to show that all of these numbers like 11, 12, 13, 14, that they are included in this set, we can put a little arrow just there, just to show that that continues on all the way up. not just on this number line that we are given, this small part of the number line. Okay, nearly the exact same question down below, except this time, like my other question, we're working with x is greater than or equal to 2. So again, 10 is greater than or equal to 2. So it's 9, 8, 7, 6, 5, 4, 3. And this time, seeing as we have this little line underneath my inequality sign, we do include the 2 because x is greater than or equal to 2. And again, we can put a little arrow there just to indicate that that's going to go on all the way up. So to round all that up, as a quick recap, if you're using real numbers, make sure you're representing that on the number line with a straight line. Make sure you use dots for natural numbers and also integers. I didn't do an example with integers, but of course they are dealing with whole numbers as well, like our natural numbers, so they're represented by dots on the number line as well. Remember that you're using empty dots at the very ends of your expressions or at the ends of your number lines for the greater than or less than symbols, and you're using filled in dots for your greater than or equal to or your less than or equal to symbols. Okay, after all that build up, we're back to part B of our question, which is this part here, and we're asked to graph this inequality. So this time, instead of just having one thing to deal with, so like we had x is greater than 3 in some of ours, we also have another part as well. So in our situation, we had something like this, but now we also have another part here to deal with. So basically what this means is we want all the real numbers that are in between -3 and 2. That's what this is saying mathematically, and you need to be able to read that, all these mathematical symbols, and reason out in your head what they actually mean. So if we think back to what we've done just in the last couple of minutes, we're dealing with our real numbers. So we will be dealing with a line on our number line. And we know that we want all the numbers in between -3 and 2. So we know that our numbers are going to start at -3 and go all the way up to 2. So what I'm going to do is, I'm just going to put a circle around the -3 and a circle around the 2. And what I'm going to do is, I'm going to draw a straight line between them. And what I've represented here is all the real numbers in between -3 and 2. Now I've got a small bit more work to do because of my inequality signs. So if we just take this part here is talking about what's happening here on my number line at the -3 part. So if x has to be greater than -3 and it's strictly greater, then that means my empty circle here is absolutely perfect, because it means that I've gone all the way down to -3, but I haven't actually colored that in. So this part here is perfect. However, if we look at the other side of things, this part here, it says that x is less than or equal to 2, and the or equal to part is the most important, the little line there underneath the inequality sign. So because that line is there, we need to include 2 in our plans. So if you look over here, the way I have it at the moment with the empty circle is incorrect because we are not including 2 in that. For the question, it says less than or equal to 2, so we need to color that in. And if I just take away all my sort of rough work there, right now, that is your question B answered. So quick recap, if you get something like this in your exam, on your number line, see where it starts and finishes and put a circle around those. Check whether it is a real number or an integer or natural numbers that you're working with. In this case, it's our real numbers. If it was natural numbers or integers, we would need dots. And if it was natural numbers, actually, it would just be the positive ones that we would have to color in. We wouldn't need anything past here. So we wouldn't need anything here if it was natural numbers. In this case, it's our real numbers. So I'm going to draw a straight line between those. And then just check on your inequalities. If it's just a -3 is less than x, then you're leaving this circle here as it is. If it is x is less than or equal to 2, then you're coloring in this one here. The part C of your question was asking you to use algebra to solve the following inequality. So for this question, your ability to manipulate equations using algebra will be called into play. So you notice with this one here, in the middle, I have an unknown, which is g, and it's the only unknown, it's the only thing I do not know in that whole inequality here. So what I'm going to try and do is isolate the g on its own so that I end up with something like this. Sorry, not a q, a g. So that I end up with something like this. Let's say 7, let's say 3. I only want the g on its own in the middle. So something like the question B that I had here, where the x was the only thing in the middle here. So we're going to treat this like an algebra equation. Whatever I do to one side, I have to do to the other. And in this case, we have actually 3 sides. So we've got the -7 side, we've got the middle side, and we've got the right-hand side. So we've just got to be careful with those. Remember, our goal is to isolate the g. So the first thing I'm going to do is I'm going to take 8 away from each one of my 3 sides. If I take 8 away, I'm just going to put that down underneath each one of those things. What I'm going to end up with is, if we just take our first segment here, -7, take away another 8, is going to give me -15. My equality sign is there. I have 8, take away 8 in my middle part here. So I'm going to have this 8, take away 8, which is going to give me 0. Seeing as it's just 0, I'll put it down here, but I'm not going to include it in the following lines after that. And I still have my -3. G, G. And at the very end, I have 11 take away 8, which is going to be 3. And I have my inequality sign there. So that was step 1. And just to take away all of those. So for step 1, I just took 8 away from each side of my inequality. And this is what I ended up with. So in order to tidy that up, we've got -15 is less than -3g. G is less than or equal to 3. Now the last thing we got to do is get the g on its own in the middle here. So what I'm going to do is I'm going to divide the middle by -3. And I'm just going to use a different color for that just to let you know what I'm doing. I'm going to divide that by -3. And if I divide the middle by -3, I've got to do the same to both sides, here and here. Now, before we go on to our next step, I'm just going to take a step aside and do some rough work here just to show you why the next line in this question is so important. So if I put down the inequality that 4 is greater than 2, you'd all believe me because that makes sense. 4 is greater than 2. However, if I multiply both sides by a negative number, so let's say I multiply 4 by -1 and I multiply the 2 by -1 as well. Actually, let me just write that a small bit better because that looks a small bit confusing. Okay, that's a bit better. So we're going to multiply both sides by -1. If we multiply the 4 by -1, we get -4. If we multiply the 2 by -1, we get -2. And our big question is my inequality here going to stay the same? Is it going to be pointing the same way? And let's ask ourselves, does that make sense? Is -4 greater than -2? And if you think about it on the number line, let's go 0, -1, -2, -3, it's 4, we got 1, 2, 3. The bigger the number is, the more to the right of this number line it is. So we can see that 3 is bigger than 2, 2 is bigger than 1, 1 is bigger than 0, and so on. As we can see, -2 is bigger than -4. So this scenario up here is false. In order to make this correct, our sign in the middle must change direction. So, if you are multiplying both sides by a negative number, or if you're dividing them by a negative number, it'll work the same way. You need to change the direction of your signs, purely because of the example that I've done here. This example works with bigger numbers, and if you do not change the directions of your signs when you're multiplying or dividing by a negative number, then your statement will not make sense, like the equation that we had here just before I changed the sign. So back to the question that we had, we're in this scenario here, and we're just after dividing everything by a negative number. So I'll just write that out again, so I have more space to do that. I'm going to do these 3 sums first, and then we'll worry about the direction of the signs in the middle. So let me take those lines away. -15 divided by -3 is going to give me 5. -3g divided by -3 is going to give me 1g, or just g on its own. You don't have to put the 1 in. And on the right hand side, so I'll just put arrows down there just to show you where they're coming from. The right hand side here, 3 divided by -3 is going to give you -1. Now, here's the part that you got to be careful of because of what we said before, because of what we said here. Our signs are going to have to change direction. So in red, my less than sign is going to change to greater than sign, and my less than or equal to sign here is going to change to a greater than or equal to sign. Seeing as you've isolated g on its own in the middle and you've done your maths correct, then that right there is your answer. So you know that g is a number in between 5 and -1, and if we go back to the question, we weren't told what g was. We weren't told that g was an element of r or z or n, but in regards to this question, it didn't tell us to plot it on the number line. There's no mention of the number line there in the question. All we had to do was show this algebraically. So use algebra to solve the following inequality. We've solved the following inequality. We know now that g has to be in between 5 and -1, so we are done. The main skills of maths that you were called upon there was manipulating this thing here to get g on its own, and also knowing that if you are multiplying or dividing by a negative number, so on this step here, you needed to change the signs of your inequalities to cater for the fact that you are multiplying or dividing by a negative number. If we take a quick look at the marking scheme out of all those questions together, 7a, that's what we wrote down, and 7a part II, that's literally what we wrote down as well. That was your 5 marks. Again, for part B, that's exactly what we did for part B. You'll notice that in the marking scheme, like that's the most popular answer because it comes up first, but sometimes people represent the starting and end points of their inequalities in different ways, but it's a lot more recognized, the part here that I've put in a square, and that's the way I'm going to teach it, so we'll forget about this part here. But that was your 5 marks. And again, part C was 10 marks, and they've done all their steps there as well for you. And just one thing to be aware of, if you had left the inequalities as they were at the start of the question, if you'd forgotten to change them, then you would have only gotten high partial credit. So you would have lost 3 marks, you would have gotten 7 if you got the 5 and the -1, but incorrect inequalities. So if you'd forgotten to change your signs. So that's that would have been a very harsh, I suppose, 3 marks to drop for yourself just for forgetting one thing. Okay, 2 more exam questions to get through. 2018, question 11, they asked you to, given a number line, you were asked to write down the inequality. So usually you're asked to write on the number line. This time you're given the number line and you're asked to do the mathematical equation. So they've done the first one here for us. And they said it's the real numbers. And the way we know it's the real numbers is it's a straight line here. In between -3 and 2, well, that makes sense. -3 and 2. And -3 is less than or equal to x. So they've filled in the dot on the 3. That's exactly what they've done. And you'll notice that they haven't filled in this dot here on the 2. So we know that that's correct. It's the one example that they've given you. Our job now is to do the other ones. So for our second one here, we have -3, -2, -1, 0, and 1, all with dots. It's not a straight line. So we know that it's not going to be our real numbers. So we just, because otherwise it would have been represented by a straight line. So we're left with an option, natural numbers or integers. And we need to know which one of these takes into account negative numbers as well. And that's going to be our integers. If you had ticked negative number or natural numbers here, that would have been incorrect because -1 has a dot in it, so does -2 and -3. They are not natural numbers. Our next step is to try and find out, well, what's it in between? And we can see it starts at -3 and ends at -1, or sorry, +1. So I'm going to put -3 here, I'm going to put 1 here, and I'm going to put my x in the middle. Now for this, we need to see, is 1 included in this set? And it is, because of the fact that there's a dot on the 1 here. So I'm going to say that 1 is greater than or equal to x. And also, for the same reason, -3 is included. So -3 is going to be less than or equal to x. So let's just make sure that we've gotten that correct. We want all the numbers that are in between -3 and 1 that are integers. Have we got that? -3, -2, -1, 0, 1. and it's including -3 and 1. Yes, we have. So that's our first question done. If there was anything there that you were unsure of, we still have 2 more to get through here. So hopefully I'll pick that up along the way. For my second one here, the numbers 1, 2, and 3 are have dots on them. So again, seeing as it's not a straight line, it's not going to be my real numbers. It could be my integers, but the best way of representing these numbers would be my natural numbers. So if you're unsure of whether it's a natural number or an integer, try and be as specific as possible. So we know these are our natural numbers. We know that it's in between 1 and 3. We know that 1 and 3 are included. So we need to write down, well, 1 is less than or equal to x, and x is less than or equal to 3. So let's just see if we've gotten that correct. Let's see if that makes sense. All my natural numbers, that's going to be here, in between 1 and 3, in between 1 and 3, and including 1 and 3, well, I've written those down. I have it exactly the same as what's on the number line there. Okay, last one, and this one is slightly different. Let me just get rid of my red marks up top here so we're not confused. So this one is different to the 2 that we're after doing. It's a straight line, so that's going to be my real numbers. It's a dead giveaway. And it starts at -2 and ends at 4. Actually, I'm going to do this one down here just to give myself some room. Starts at -2, ends at 4. I'm going to put the x in the middle. And this time, my circles here are not filled in. So my 4 is going to be strictly greater than x, and my x is going to be strictly greater than 2. I can't put the equal sign underneath those because that would mean that these 2 circles are filled in, which they are not. So if they're not filled in, don't put in those at the bottom. Those are 3 questions done, and here are the answers in your marking scheme. There's 10 marks going for all of those, which we've gotten correct, but you'll notice that there was a couple of different answers for these as well. So let's take, for example, our second one here. They just said that x was less than or equal to 3 and x was a natural number. They didn't put greater than or equal to 1 as well, but we were sort of just being careful with our answer for that. We wanted to give the most information possible. So right down here, or any other valid inequality, that just means that there are slightly different answers that you could give that will give you your full marks. For example, looking at this part again, you could have had x as an element of your integers or x as an element of your natural numbers if you did it this way as well. And if you want to pause the video here and check out if this here makes sense, you can be my guest. But just be aware, for this question there were full marks going for slightly different answers to the ones that we are given. Okay, last exam question. This came up in 2016, and again we're back to number lines and putting numbers on. So very quickly, x is less than 4, where x is a natural number, so they want all the natural numbers less than 4, so that's going to be 1, 2 and 3. Now they want all numbers less than 4 where x is an element of z, so that's going to be all your integers. So now we've got 3, 2, 1, but now we can include 0, 1, 2, 0, minus 1, minus 2, minus 3, minus 4, minus 5. And if you want to put the arrow there, you can. And finally, x is less than 4, where x is an element of r, so x is your real number. So x is less than 4, can't be equal to it, so we're going to put a circle around the 4. We're going to put a line all the way down because it's our real numbers, and we're going to put an arrow there to indicate that that's going to go all the way. So the only thing that was different between these three questions was this, this, and this. And the question was asking you basically, do you know the difference between representing your natural numbers, your integers, and your real numbers on a number line? Do you know how to represent them with dots? Do you know, in this case here, how to represent that with an empty dot? And how good you are at working with your number line. There's the marking scheme. There was 5 marks going for that. And that's exactly what we have in our question here. Okay, that's basically all I wanted to go through today. We had a good look at number lines and the different types of numbers and representing things on the number line, including your inequalities. We also solved an inequality question. Your key points are here as follows. Again, they're going to be in the description below. The main things that we had to look at today that was new was this part here, down below. This was all done in my previous video and briefly at the start of this one. If there's anything I've forgotten, I'll put it in the description below as well, so just have a read through that. But other than that, that's all from me on inequalities and the number line. Thanks for listening.